Welcome to this explainer. Today we are taking a pretty wild journey. We're going to start right in the palm of your hand and travel all the way out to the abstract future of global economics, all through the lens of the latest advancements in artificial intelligence. We're living through an incredible transition right now, and the very foundation of how we interact with AI is fundamentally shifting.
So think about this for a second. What if your AI literally never needed the internet? For the longest time, we've just assumed that to access truly powerful artificial intelligence, you had to be tethered to the cloud. You ask a question, it beams up to some massive server farm, and an answer beams back. But guys, that paradigm is fracturing as we speak.
And that quote right there hits the nail on the head. The ultimate appeal of local AI is complete privacy and absolute control over your own data. As pointed out by the YouTube channel Teachers Tech, Google's new Gemma 4 models are designed to run entirely on your own hardware. Your prompts, your proprietary code, your personal questions, none of it ever leaves your machine. No API keys, no subscriptions, no limits. This offline fallback isn't just a neat little party trick. For a lot of developers and privacy-conscious users, it is now a hard requirement.
Here's our roadmap for today's explainer. We'll start with AI on your terms, then hit the hardware reality check, explore pushing consumer limits, zoom out to the speculative AI economy, and finish up with the new frontier. Let's get into it. Section 1. AI on your terms, bringing artificial intelligence to your everyday devices.
So what's actually making this possible? It comes down to a brilliant architectural shift called intelligence per parameter. Basically, you don't need a massive server farm to get high-quality AI assistance anymore. Instead of just making the model massively bloated, Google engineered Gemma 4 to squeeze way smarter results out of far fewer resources. By pairing an embedding model alongside standard parameters, these smaller models, like the E2B and E4B, give you responses that feel like they're coming from a much larger, incredibly expensive model, except it's running right there on your everyday device.
2.54 gigabytes. That incredibly small number is the actual download size for Gemma 4 E2B, which amazingly can be run completely offline directly on an iPhone 15 Pro Max. According to the tech reviewers at XDA Developers, if you use Google's Edge AI Gallery app, it takes just a couple of minutes to download. Boom, you instantly have a fast, fully offline AI right in your pocket.
Moving on to Section 2, the hardware reality check, cutting through the noise of AI benchmarks.
Now, things get really interesting when we compare Gemma 4 against its biggest open-weight rival, Llama 4. The crucial point here is that while Llama 4 uses a mixture of experts' architecture to save compute power, it creates a massive VRAM trap that basically prices out most home hardware. Think about it. Llama 4 Scout only actively uses 17 billion parameters to think, but you still have to load all 809 billion parameters into your memory just to turn it on. It really doesn't matter how efficient the compute is if you literally cannot fit the model into your graphics card. Plus, Gemma 4 operates under a highly permissive Apache 2.0 license, which means enterprise legal teams don't have to sweat over compliance issues, unlike with Llama 4's strict community constraints.
You can see the hardware reality crystal clear right here. Gemma 4 scales beautifully, from older 6GB cards all the way up to high-end workstations. For your everyday developer, that Gemma 4 E4B model is an absolute game-changer because it fits so comfortably on a standard RTX 3060. Meanwhile, Llama 4 Scout, it demands you have a top-tier RTX 3090 with 24 gigs of VRAM just to get in the door, and even then you're forced to run it at extremely aggressive quality-degrading quantization levels.
2150. That massive number is Gemma 4 31B's Codeforce's ELO score. To put that into perspective, the previous Gemma 3 model had a score of just 11. Jumping from 110 to 2150 is not some minor incremental update. It represents a qualitatively different class of programming capability. It absolutely cements it as the ultimate local coding assistant. If you're a developer looking for a daily driver to write and debug code entirely offline, the data overwhelmingly points to Gemma 4.
All right, Section 3. Pushing consumer limits. What happens when enthusiasts take control?
This is where the community just blows my mind. Standard wisdom dictates that the flagship 31B model absolutely requires 24 gigabytes of VRAM. But by aggressively managing memory, one Reddit user completely defied that. They leveraged a specific build of llama.cpp with TurboQuant and intentionally offloaded the visual processing components to standard RAM to free up space. The result? They built a highly complex autonomous AI character system locally on an RTX 4080, achieving speeds of 40 tokens per second for a massive 31 billion parameter model. That is wild. And what they built with it is even cooler. Check out these 6 specific memory layers. This user realized a fundamental flaw in most AI systems. When an AI tries to compress dialogue into a narrative summary, it hallucinates. It just makes things up. Those fake details get saved as facts, and suddenly the AI remembers things that literally never happened. But by structuring memory this way, especially using atomic facts, which are verified logic triples like subject, predicate, object, they avoided standard summaries altogether. This prevents the AI from hallucinating fake memories and creates a robust, multi-layer psyche that behaves incredibly like a real character.
And of course, the open source community never sleeps. Thanks to the highly popular tool Unsloth, enthusiasts can now fine-tune these models locally on super accessible 8GB graphics cards. The speed at which this community moves is staggering. Within days of release, developers were patching critical bugs that caused training losses to explode and audio to overflow. Unsloth actually allows users to train the Gemma 4 E2B model up to 1.5 times faster while using 60% less VRAM than standard setups. This is quite literally democratizing AI development, shifting the power from massive tech corporations right into the hands of home coders. Let's zoom way out for Section 4, the speculative AI economy, the macro ecosystem of the RQ-18 initiative.
So shifting gears from what you can do on your laptop, let's look at how massive organizations are trying to turn AI into closed-loop economic systems. Enter the GENII quantum economy. Their goal is to use AI to completely strip out inefficiencies and middlemen, passing those margins directly back to the participants. Instead of using AI just to write code or draft emails, this initiative uses predictive algorithms to manage physical assets, specifically agricultural land. They are attempting to build a consumer-to-asset economy that claims to provide guaranteed returns by optimizing every single step of the supply chain.
To really wrap our heads around this private orchard analogy is perfect. It beautifully clarifies how participants shift from simply buying products to actually owning a piece of the yield-generating ecosystem. You aren't just an end consumer buying an apple at the store. The ARQ-18 initiative acts as your membership card, and the GENII AI is the master gardener. Because the AI operates with perfect efficiency, removing all that traditional supply chain markup, your tokenized share of that orchard theoretically grows more valuable over time, completely insulated from standard market volatility. This creates what they call a self-reinforcing flywheel. Consumers join the closed-loop network, demand for internal products naturally spikes, the system buys more agricultural land, production yields increase, and those higher returns attract even more participants. It is a fascinating, highly speculative cycle where AI algorithms theoretically guarantee returns by continuously optimizing this microeconomy. It's an incredibly ambitious attempt to engineer an entirely self-sustaining system using artificial intelligence as its very core.
Finally, Section 5, the new frontier, choosing your path in the AI revolution. Because systems like GENII aren't just quirky financial tools, right? They represent a radical, macro-level attempt to reshape human society using artificial intelligence. This triple helix integration of academia, industry, and government is pushing for what they call a resource-based economy. It's a grand vision where AI dictates the sustainable allocation of finite resources, completely transforming how value and wealth are distributed globally. We are looking at a spectrum of AI integration that goes from a tiny app on your iPhone all the way to an automated, land-backed financial governance system.
I hope this explainer has really illuminated the sheer crazy scale of the AI revolution happening right now. The tools to build your own local, private, offline intelligence are completely free and available to you today. But at the exact same time, these vast macroeconomic systems are being designed to absorb us into engines managed entirely by algorithms. The technology is here, the infrastructure is being laid, the only question left is, in this new digital frontier, will you choose to be the independent architect of your own models or an integrated asset in a massive AI economy? Thanks for joining me on this one. I'll see you in the next explainer.